I cut my hand while doing Galileo's experiment to show that object in free fall is speeding up as they're getting closer and closer to the ground. When I drop a ball, why does it fall? In fact, all mysteries of gravity contains in this simple action, dropping an object. So physics works. 1 kilogram ball did not break the glass when I drop it from 50 centimeters above the ground. Why it didn't break the glass when I drop it from 100 centimeters, but why did it break the glass when I drop it from 150 centimeters? Gravity is a mysterious force. It binds every single body together in the universe. It also allows us to exist here on the earth. But it boils down to a simple question. How do objects fall? To understand it, I'm going to take you 1590 at the University of Pisa, where a 26-year-old man, a 26-year-old mathematics professor dropped feather and hammer at the same time from the same height. I'm going to do the same experiment from Columbia University. Welcome to Columbia University. I pursue my doctoral here at Columbia University. Pretty soon, people are going to call me Dr. Bailey. The reason I bring you over here to do a famous experiment first done 1590, some 400 years ago by Galileo, to understand the behavior of falling body. Now I have a heavy object on my one hand and a light object on my other hand. When I drop them at the same time, they will start falling, and we'll try to understand their behavior. Now let's do that. Now some people would say that hammer touches the ground faster because it has more mass or it has more weight. But mass or weight has nothing to do with it. Air resistance. I will demonstrate it by using two umbrellas, same size, same mass and same weight. They would fall at the same rate and touch the ground at the same time. But what if I open one umbrella? Then the open umbrella will fall slower. In 1590, 26-year-old Galileo understood that feather and hammer would fall at the same rate and touch the ground at the same time if you can remove the air. We can show you that taking you to the moon, because there is no air on the moon.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon? How about that? Mr. Galileo was correct.
Another puzzle is speed. To understand the speed of a falling body, Galileo again dropped. But it's pretty difficult to see whether object fall with constant speed or it picks up the speed as it getting closer and closer and closer to the ground. So Galileo did a very clever experiment. He dropped an object from very close to the glass. And he did the same thing from higher up. And he saw a big difference. That tells us that the falling body travels quadratically, and as it speeds up and it gets closer and closer and closer to the ground, because there is a mysterious force called gravity that supply the acceleration, which we call acceleration due to gravity. Galileo gave us 4 hypotheses. Number 1, the displacement or distance of a falling body increases, of course, quadratically, and then the speed or velocity of a falling body increases linearly, and acceleration remain constant. So these 3 ideas, Galileo's these 3 hypotheses really based on the one thing, and that is when you drop a heavy object and a light object, they fall at the same rate and hit the ground at the same time if you drop them from the same height. Why Galileo had to use the ramp? 1590, when Galileo was 26 years old and he dropped feather and hammer, there was no stopwatch, so he had no way of verifying his own hypothesis that falling bodies' speed increases linearly. So he had no option but to use this idea of ramp. I'm going to do it exactly the way Galileo did. I'm going to use the sound. So I'm going to create a ramp. And I'm going to drop it from 0.2 meter, 0.4 meter, 0.6 meter, 0.8 meter, and 1 meter. This is the data I collected. So let's find the velocity. Velocity is distance over times 2. Why is that? Because let me prove it. So velocity is Vf plus Vi over 2. Also, velocity is df minus di over tf minus ti. This is 0, right? And this is 0. So v is equal to vf over 2 is equal to v is equal to df over tf. Now, instead of vf, you can call v over 2 is equal to v is equal to d over t. All right? So you can say v equal to v. So v over 2 is equal to d over t. 2d over t. So v is d over t times 2, and that's where it is. You see over there I wrote. Okay, good. $1.9. Alright, so Galileo said that object is speeding up. How do you know? He dropped a rock from 1 centimeter above the ground and same rock from 2 centimeters above the ground on his hand. So which one causes the more pain? The one that he dropped from 2 centimeters above the ground causes more pain. Alright, so that's how he know that object is speed up if you allow the object to spend more time in the air. Plus half at squared. So VAT is 0, d is equal to this, 0.2, 0.2 is equal to half a, and then 0.83 squared. So a is equal to 1.7, 1.7, 1.7, because acceleration is constant. You can find it out.